What I want to do here is replace these two forces with a single force and a single moment acting at point O that has the same external effects on the system. Okay, so rather than having these two forces, I just get a single force and a single moment at one location, and they will effectively be the same as far as like external forces. And the way I do this to is first things first, I find the resultant force, right? The total force. And that's really easy. You just sum up all of the forces here. So that resultant force is just, adding F1 and F2. Very simply, you get minus 30I plus 15J plus 45K. Okay, and that'll be pounds. And that's the resultant force. Okay, so again, what we're trying to do here is I'm going to create an equivalent system. Okay, I'm going to take all of these forces and move them over to my O point right here. So I'll have my O is right here. So I have my resultant force there. Now when I do that, okay, the F1 and F2 about point O were creating moments. When I move them to point O, that force is no longer going to create a moment about point O. So I need to include the moment that was there. Again, this is an equivalent sort of system where I take everything and basically move it to a single point. Okay, but again, I can easily move those forces and just add them together. However, I still need to include the moments that those were creating about point O, because now that force I've placed at point O can't create its own moment anymore. So I find the resultant moment. And the equation for that resultant moment is just adding up any of my couples, which I don't have here, but if I do have any couples, remember those are free vectors. I can just add those together, okay? Plus any r cross f's, and that's what I will need to do here. So again, for us here, this will go to 0, okay? And then I'm going to do r cross f's for 1 and 2. And again, that r is going to go from point O to each of the forces, okay? Because again, that's the moment that was being created by those forces. When I move it over to point O, it can't do that anymore because I don't have a moment arm. So I add this couple moment that's equivalent to r cross f of each of those forces. So moment 1, okay, this is the r vector from O to force 1, which will be 1.5 in the I plus 2 in the J. And I'm going to cross that with that force, which is given to me as negative 20I minus 10J plus 25K. Doing that cross product, I get 50I minus 37.5J plus 25K. Again, this is the moment that force 1 was creating about point O before I moved it over. Now that I've moved that force to point O, I need to also include this couple moment at point O. That was what F1 was doing when it was at point O. Okay, so I'll do similarly for M2. This time my R vector will be 1.5I, but then 4 in the J direction, and then it moves up 2 in the K direction. And I'm going to cross that with the given force of negative 10I plus 25J plus 20K. So again, what I'm calculating here is the moment that F2 was creating about point O. That now I'm going to include as a couple moment because I've moved F2. It can't create that moment anymore because it's at point O, so I need to include that. So that cross product gives me 30I minus 50J plus 77.5K. Adding those together, I can find that my resultant moment, just adding the I's, J's, and K's together, I get 80I minus 87.5J plus 102.5K, and that will be foot-pounds, okay? And what that is is it's a resultant moment or a new couple moment that I'm going to place at point O. Now, these two guys are equivalent systems, right? I can either have those two forces at those two locations, or I can have this single force at point O along with a couple moment, okay? So it's just a way of taking forces all over the place and condensing them down to a single point.